Good afternoon, everyone, and thank you for attending today's webinar on Beyond the Brick Masonry Wall Assemblies to Optimize Performance with our Wall Systems Research and Development Manager, Leroy Danforth. My name is Brian Yansak, and I am the Design Studio and Events Coordinator for Glen-Gery. During the presentation, you will notice the Q&A function at the bottom of your screen. Please feel free to submit any questions throughout the presentation, and they will be answered at its conclusion. Your attendance will be marked, and we ask that you stay on for the duration of the presentation to receive credit. Everyone attending the duration of the course will be receiving a certificate of completion within the next few business days, and those who provided their AIA number during the registration will be submitted for AIA credit as well. If you're participating today but did not register and wish to receive credit, please email events@glengery.com. That's events@glengery.com with your AIA number, and I can submit for you. Today's session is also being recorded, and a link for you to access it will be provided within your certificate of completion. I would now like to introduce our speaker today, Leroy Danforth. Leroy is a licensed professional engineer who has provided technical guidance to the building community for more than 20 years. Leroy's contributions include a variety of technical articles and publications on brick construction, participation in the development of masonry codes and related standards, and advancing industry knowledge via hundreds of continuing education seminars. Leroy's current work focuses on testing, development, and technical support innovation of non-traditional masonry assemblies. Leroy earned a bachelor's degree in architectural engineering from North Carolina Agricultural and Technical State University, and also holds a master's degree in construction engineering from the Catholic University of America. And with that, I would like to turn it over to you, Leroy.
Okay, thank you, Brian. First of all, I want to just thank everyone for being on with us today. We know that you have a choice of many webinars that you can attend. In fact, there was one that I actually wanted to be on one right now. I have to get my continuing education credits, and I have to continue to learn things so that I can do presentations like this for you. So again, thank everyone for being here with us today. There are a few things that I would like to share with you about our company in case some of you aren't very familiar with us. Glen-Gery is one of the oldest and largest brick manufacturers in the United States. We were founded in 1890, so we're a little over 130 years old at this point. We were acquired in 2018, Thanksgiving Day, by Brickworks, which is another old and the largest brick company in Australia. And so that junction between the two has really launched Glen-Gery into some new things. We have over 500 distributors across the United States, Canada, and we operate, I'm not sure exactly how many manufacturing facilities we operate at the moment, but somewhere around 9 or 10, which includes not only brick plants, but we have our own manufacturer's facility in Cynthiana, Kentucky as well. There are a few products that I'd like to draw to your attention to. The San Selmo. This is a long format brick. This is part of our import line. These brick come from Italy. So if you like that long linear look, something that has a bit of a texture to it, this is something that can work well for you. These are brick that are 20 inches in length. Venetian glass is another part of our import line. Obviously, you can do some very beautiful and unique things with these, whether it's accents or features. Our clay coat line gives us the ability to give you those true cool gray colors that are hard to achieve with normal brick manufacturing. This is a coated brick, but coating is breathable. It's not a glaze, it's fired and becomes a part of the ceramic. So this is a very good option when you're looking for those, basically anything in the range from black and white. We can also do these in colors and some textures and things as well. But a good option if you need a breathable coating. We are one of the very few manufacturers of handmade brick in the United States. So if you have a project that is brand new but needs to look like or needs to match 200 or 300 or 3,000-year-old brick, we have the ability to do that through our handmade line at our York plant. The Roman Maximus is another long format brick. This is a nominal 24-inch long brick, but this one is made right here in the United States at our Adel plant. So we are proud to offer that again if you like that long linear format brick, which has really become popular in the last couple of years. We have a couple of options in the manufactured stone line. One is Creative Minds, which is a really high quality, sort of over engineered, really unique texture product that we have available. And also Landmark, which is the line that we make in our Cynthiana, Kentucky plant. We still make pavers. Feldhouse is also part of our import line. This is something that expands our thin brick option and availability, especially when it comes to extruded thin brick tile and things that would be used, for example, in precast or embedded type applications. We also make our own thin brick support systems. This is a look at the true brick system, which is a rail or channel that uses special brick that are grooved to give you a really secure mechanical attachment. So that's one option that we have. And the other is FinTech, which rather than a rail or channel is a panel type system that has support ties that support the brick and provide a mechanical interlock through the mortar joint. And this one can be used with basically any kind of thin brick. So those are the two options that we have there. So the main thing that I wanted to share with you is that we are probably, without question, the most versatile brick manufacturer in the United States. There are things that we do that I didn't even mention, like our glazed brick, for example, one of the few manufacturers of glazed brick in the United States. So when you take a look, these are the values that drive us. We care about our environment and the people. We try to be sustainably safe, to innovate along with everyone, everywhere, every day within our organization, to collaborate with you to make sure that we succeed together, to do what we say, which is our integrity, to lead, to inspire people, to make sure that everyone is doing their best, and to try to exceed your expectations by playing to win, putting our everything into it. So that's just a little bit about us, and that brings us into our program today. These materials are copyrighted, but if you would like a copy of the presentation, this is being recorded, and when you receive your certificate, there will also be a link to a recording of the presentation. We're happy to share that with you. Glen-Gery is a registered provider with the American Institute of Architects, and this program is approved for 1 hour of continuing education credit, and this is an HSW program. So what's actually in the program? What are we going to talk about today? What we're going to talk about is everything behind the wall, within and behind the brickwork, which is really most of the wall assembly. The brick itself is just brick and mortar. That's probably the simplest part, but really makes the walls perform the way that we intend them to control heat, air, moisture in the assembly, are all the materials that we use in conjunction with the brickwork. So those are the areas we're going to focus on today. So we're going to talk about some basic components of masonry drainage wall assembly. We'll talk about compatibility issues between those components. We're also going to talk about installability, how user-friendly some materials are, how they tend to work together. And along the way, we'll give some examples of proper specifications. We'll give you some suggestions on how to specify the appropriate materials that are compatible with the materials that are around them, and that you can get the best performance out of. So here we can take a look at our actual learning objectives for the program, which are to identify the basic components of a masonry cavity wall. We'll look at compatibility of the common elements, which are flashing, air barrier, insulation, some of the sealing products based on published information. We'll discuss some of the characteristics of these components that make installation easier and enhance performance. And as I mentioned, we'll look at actual spec language and examples that help to ensure the compatibility of the assembled components. So we know that masonry is often chosen for a building because of its beauty as well as its durability. Aesthetics, of course, is the fun part where we get to explore creative ideas, colors, textures, all that stuff that make a lasting impression for the customer. There are many attractive cladding materials. Brick isn't the only one. But a consistent selling point for masonry is the longevity of masonry buildings, with an expectation that they'll be around longer than we will. So although we often take this as a given for masonry, if we take a keen eye toward building performance, we can ensure that that happens by focusing on the two or a couple of the issues on the right hand. That will be the main themes of our discussion today. Those are compatibility and installability. So when we have this junction of aesthetics and building performance, that's when we can have a building that lasts 200 years, but also looks the same, maintains that aesthetic, so that in 200 years it looks the same as it does today. So the first concept we'll introduce here today is compatibility. And our challenge in regard to compatibility is to make sure that we're maintaining specifications that keep up with all of the new products, as well as how they fit with the new codes as codes change. We know that keeping specs updated can be difficult because you as designers have many things that you have to deal with at once. So whether you're doing it yourself or you have spec writers or you use wall consultants, the specification language may come from a variety of different sources. They may come from software or somewhere like master spec, or they may be recycled from previous specifications. But despite this, we still rely on the contractor to some degree to do the right thing. It's our job, though, to help him out as much as we can. So that brings us to our second theme for today, which is installability. And I can tell you that I am one of those people that hates made up words, but there's a reason we've sort of coined this phrase here. It's one that we can all understand. And basically what we're talking about here is knowing what products are user-friendly. As product innovation makes things easier to install, we can lose some of our traditional skills. We've seen some of that happening. As an example, in 2021, despite the photo that you see over here on the right, there are not a lot of young people that are lining up to lay brick. The average bricklayer in the United States is 55 years old, and they may be unfamiliar with the newest products and the newest technology. So this is an opportunity for you as designers to consider the preferences of the contractors and to point them in the right direction. Here's the thing, they are always going to explore options that cut costs. Some of these will be good options, some will be not so good, but your understanding of installability and compatibility may help to prevent the use of inferior products, as they explore how to cut costs. So our company has made brick for 130 plus years. And the result of that is we have some long-standing relationships with contractors and manufacturers of materials that are used within and behind the brick. This gives us a unique understanding and ability to partner with the products that are not only compatible, but also provide the highest levels of performance and support, which positions us as a resource for you as a designer. So this is an opportunity for me to, all those smiling faces that you see in there in the center, that is actually the team that I work with. And we're able to provide support. I look at the faces on that team, and we have people who specialize in thin brick and precast and embedded masonry. people who are just knock it out of the park, salespeople. We've got a shape specialist on the team. We've got installation specialists on the team. We've got people with background in manufactured stone, people who were ceramic engineers, designers, estimators, mason contractors. And so, again, it puts us in an opportunity, puts us in a position to really be a resource to you as a designer. So as we actually get into the meat of today's program, what we're going to do is we're going to highlight each of the components that you see here on the screen that you'll find in a typical drainage wall assembly. And we're going to explain why each one of these is important and review some of the applicable industry best practices for each one of these. One of the things that you will notice in this program is that a lot of the images are provided by a couple of sources. That's not because we're playing favorites, it's just because that's where they are available, easily available, and illustrated the things that we wanted to see. So just wanted to make that clear. So the first thing that we'll begin with today is joint reinforcement. Joint reinforcement is one of the ways that you can anchor a brick veneer to its back. The reason we begin with joint reinforcement is as you look through Division 4, which is the masonry division, you'll often find joint reinforcement right after the brick and the mortar. So joint reinforcement is one of the most common ways to connect brick to CMU or concrete masonry. It was introduced in the 60s to replace masonry headers and accommodate the movements that are related to the temperature and the moisture changes that happen, among the different assembly components. So on the left there's a look at what the specification section for the joint reinforcement might look like. And you can see a number of materials there. All right. So simply, joint reinforcement can be separated into two types, either ladder or truss. There used to be a tab type as well that was fairly common, but I don't think that's used quite as often anymore. So if we take a look at ladder and truss, truss type was the one that was initially used more often. However, that has changed over the years. Ladder type is probably more prevalent now. And that's because most of our walls are reinforced and grounded to give them some additional structural capacity. So with the introduction of vertical rebar, when you take a look here, you can see that because of that diagonal wire in the truss type, that would actually, it has the potential to interfere with your rebar placement. And so because of that, organizations like the National Concrete Masonry Association, or NCMA, suggests that truss should not be used in reinforced or grouted walls. So another common area that we find for improvement of joint reinforcement and specifications is the thickness of the wire. Joint reinforcement is commonly available in 9 gauge as well as 3/16 inch, and a 3/16 inch wire is considered heavy duty. Masonry code provisions only allow the wire of veneer ties to be half the mortar joint thickness. So we know that typically you're going to specify your mortar joints to be a 3/8 inch. That means that 3/16 is okay per code. It meets the code requirement, but thicker is not always better. Okay, so here we hit our first theme. We have to remember to consider installability. So if you take a look here, this would be the spec section for a 3/16 inch diameter wire. Now think about your placement tolerances for your masonry. Your bed joint that this wire is going to be in has a placement tolerance on the thickness of plus or minus 1/8 of an inch. So 3/8 of an inch minus 1/8 of an inch means that your mortar joint is only 1/4 of an inch. So considering normal tolerances, you can have a bed joint or bed joints on your job that are only 1/4 of an inch thick, and they're okay per code. But that means that your wire, your 3/16 inch diameter wire, is now, well above half the thickness of your mortar joint. Um, the result of that is that that wire will now only permit 1/16 of an inch of mortar coverage. And simply that's not going to provide us the performance that we're looking for. In fact, you may even end up with a situation, your galvanizing is also going to increase the diameter of the wire a bit. The surfaces of the block can vary due to the texture and so on. Surface of the block courses, there's a tolerance in there being level and true to a line. So when you consider all of these things, the block can actually be sitting on top of the wire without really any mortar coverage at all or embedment in the mortar. So that's going to reduce the effectiveness, and also it puts an unnecessary responsibility on the contractor to ensure or try to ensure that he gets that mortar coverage. So for that reason, our opinion or suggestion is, our recommendation, to specify the heavy duty wire, 3/16 inch wire, only when it's necessary to do so. All right, so to summarize, our general recommendation, here you see it in the specification section, is for the 9-gauge wire, which is also sometimes referred to as a W1.7, and the ladder type for most applications, particularly if it's going to be grouted and reinforced masonry. Of course, there are going to be applications where other options may be appropriate. You may need that additional capacity of a 3/16 inch wire on your joint reinforcement, and you may need to do truss type for some other reason. All right. So the next material that we'll discuss is the adjustable veneer ties or anchors. These, of course, perform the same function as joint reinforcement, and they provide the best solution when connecting the veneer to backing structures like wood and cold form metal framing. Joint reinforcement can't be used with these backings because there's no CMU to lay it on. However, adjustable veneer ties can be used to anchor brick veneers to CMU backings. Okay, so these can be used with CMU, but joint reinforcement can't be used with stud assemblies. All right, so according to BIA, veneer ties have 3 basic functions, which are what you see listed here. They have to securely attach the veneer to both the veneer and the backing, providing a connection between the two. They have to be able to transfer lateral loads between the veneer to the backing, and they have to be able to accommodate differential movement. So here you can see a number of different configurations for the veneer ties, and all of them either have a plate, some sort of a plate or a barrel. That is going to be your connection to the backup. And then they all have either a pintle or some sort of triangle. And that's going to be the portion that is embedded in the masonry, in the mortar joint. So for our discussion today, let's add a 4th function, acknowledging that most of our walls will include continuous insulation. Because that insulation might be part of the water, air, or vapor control strategies, anchor manufacturers have been forced to consider the effects of all the penetrations that are made by the ties. So many of your ties are now available with seals or gaskets or washers, which has become or can become particularly important when the ties are installed after the insulation. So here's a simple way to categorize veneer ties. You can classify them as either inboard meaning that they're installed before the insulation, or outboard, meaning they're installed after the insulation. So, in other words, it describes a position of the veneer tie relative to the insulation. This is, for those of you who are taking notes, this is one of the most important parts of the presentation. So when you specify ties, the type of insulation that you use should definitely be a consideration, right? So the best way, or one of the best ways to describe or illustrate this, is probably with a video. So we'll take a look here, and I'll describe it as it goes. All right, so here we have our studs, our sheathing, our air barrier, and our flashing with the term bar. And our anchor, the backing for our anchor, is going to be located on the stud. You can see we have two fasteners there. This could be improved if there's a washer or a gasket to preserve the continuity of the air-water barrier. So then you have your insulation sheets, which should be coming here. Here they come. Okay. Your insulation sheets in this case with an inboard tie is going to be installed in 16-inch heights. You can't use a 4x8 sheet. More joints is going to mean more detailing. So basically you saw the mortar bed going on, and then the hook or the embedded portion of the tie. You want those to be at least 1.5 inches into the brick. That's the code requirement. A good target is about 2 inches. So that helps you with specifying the length of your ties. So this is similar to the tie that we saw used, the inboard tie we saw used in the video. So one of the things that I want to make sure that you're aware of is that there are some limits to using this type of inboard tie. And it's particularly related to the span or the distance between the back of the brick and the face of the insulation. All right. So as of the 2016 Building Code Requirements for Masonry Structures, which was incorporated into the 2018 IBC, the maximum distance, what you see here on the slide, from the back of the brick to your backing, which backing in most cases is going to mean the face of the stud, is 6 5/8 inches. However, with this inboard tie configuration, the backing part has to do most of the heavy lifting. The adjustable part of the tie can really only span 2 inches in that cavity space. So basically to the face of the insulation, which can't be more than 2 inches from the brickwork. If you're still under the 2015 code, the maximum 2015 code was actually 4.5 inches rather than 6 5/8. If you have anything more than this, a tie analysis is required. And that just makes sure that the ties have the capacity to properly transfer the lateral loads. Okay, so now we'll take a look at a video of an outboard tie. So in this case, you can see that the stud is there, the sheathing is there, and the insulation is already in place. And you can see that this tie actually has a seal for both the air barrier as well as the insulation. So in this case, one of the things that this allows is that since you're going through the insulation in this case, you don't have to fit in between your ties. Your ties are going on later, which means you can use a full 4x8 board or sheet. So that reduces the amount of joints and resulting detailing that needs to be done. It also reduces the amount of labor that's required. So here's a recap then of what we consider best practice based on the insulation type. For mineral wool and spray foam, we recommend we recommend inboard ties. For extruded polystyrene and polyiso, we recommend outboard ties. And as we go a little further down the line, we'll explain some of the reasons for those. So if you take a look, here is a potential specification section, the way that it could be worded. And in this case, what you'll see that we've done is we've actually provided an option for the contractor while giving a recommendation. And it gives the contractor the flexibility to work with materials that he's experienced with. Why do we want to do that? Installability. If he's working with something he's experienced with, you're probably going to get a better installation. So this is an example of a way that you can incorporate that into your specification. The third component that we'll take a look at is flashing. When it comes to flashing, it's really more of a system than an individual component. Flashing always works in conjunction with weeps, and in a lot of cases, we'll also use a drip edge, which is considered best practice. So flashing, among everything that we'll talk about today, is probably the material that provides the most glaring reasons to consider both compatibility as well as installability. So according to Zurich, who is one of the largest insurance companies in the construction industry, 80% of all construction claims are for uncontrolled water penetration or condensation. So if the primary function of flashing is to prevent water intrusion into directed outward wall, stands to reason this is a very important, if not the most important component among what we'll talk about today. So not only is it number one, you can see the little list of things that we have to control for over there on the right, but number two, which is there, is a distant second. Joe Stiebrecht, who some of you will be familiar with. He's one of North America's foremost building scientists. One of the things he's quoted as saying is, "You won't ever receive a call at 3 in the morning because your building is leaking air." That's certainly not the case when it comes to water leaking into a building. So again, just underlines the importance of what we're talking about here. So when it comes to flashing, we want to consider the physical properties that are listed on the slide here when we're selecting flashing materials. Obviously, they have to be water resistant. They have to be durable. Durable meaning they need to be resistant to puncture and tear, in addition to other things. Our flashing system is only going to be as strong as its weakest point. And so that's why puncture and tear resistance becomes so important. This system also has to be compatible with the sealants, the adhesives, the insulation, the air and water barrier that it's going to be integrated with, all of these different materials. And things move so quickly in our industry, and there's so many available wall configurations that there are materials out there that are not compatible with each other. So one of the reasons that restoration contractors are actually stay in business is because of flashing issues. This is not an area to cut costs. It costs about $300 a linear foot to replace flashing. And that's if you're replacing it at the first floor. If you're replacing flashing on a high rise, up on scaffolding, that could double or triple the price. So puncture and tear resistant, water resistant, resistance to ultraviolet light may be something that can become important and varies among materials. It also needs to be resistant to corrosion. Last thing to consider would be the life of the flashing material. And the life of the flashing material you choose really should be the same as the life that you expect for the brickwork or the veneer or the cladding for the building. And that's because, it costs so much to replace. You want to make sure that that's something that you don't have to do. So let's take a look at some types of flashing that are available. And we're looking at it from a good, better, best sort of framework. One of my colleagues who put this program together said there's no bad flashing because any flashing is better than none. So the three options that we show here are widely used in the United States and sort of ranked according to both installability as well as compatibility with other materials. So we begin with self-adhesive flashing. It's commonly known as peel and stick. One of the most common materials in this category is probably rubberized asphalt. Things like this, materials like this, masons love because of its flexibility, workability. It's easy to form end dams and corners. One of the things to be aware of, materials in this category generally are not as UV resistant as some others. But the biggest drawback is that there are some compatibility issues between some of these materials and some sealants, insulations, and air barriers. So here's an actual chart from the Air Barrier Association of America's Flashing and Terminations Committee. And if you take a look on the left, this column on the left lists a number of different flashing materials. And then across the top, that top row is air barrier materials, which include some insulations that can be used as air barriers. So if you take a look across the line where rubberized asphalt, peel and stick, if we use that as an example, you can see that there's quite a bit in red and yellow going across that line. The same is true for copper fabric, which is an asphaltic material, and also for asphaltic EPDM. All right, so you can see there are some compatibility materials with some issues there. And just to be clear, the reason why I showed you all three is that it's asphalt that is the issue. And so as a result, it's actually being phased out of a lot of the flashing materials that are on the market today. So this is just an example of the compatibility issue with asphalt. If you take a look at the two photos here, you may have noticed this on a project before, where there's a little bit of drool of the flashing material. So to explain rubberized asphalt flashing, as an example, this is sort of the breakdown what it's made out of. So there's like an 8 mil polyethylene sheet, which has been described as the workhorse of the product. This is what takes the abuse and protects the rest of the product. Most of it, though, is your asphalt. Right? So your asphalt here is what actually gives the product its durability. You always need a drip edge with these products because the asphalt is UV sensitive. Well, the drip edge is metal. It's probably going to be stainless steel. Maybe it's copper or something else. But whatever it is, if it's metal, it's going to be a good conductor of heat. So remember, good installability, not so great from the standpoint of compatibility. Asphalt melts at about 160 degrees. And on a 180-degree day, when you have a metal drip edge sticking out here, which is a good conductor of heat, you're probably going to reach temperatures at or above that if you're at 80 degrees or over. In that case, your asphalt can turn to liquid, and at that point, all that's left to protect the building is the polyethylene sheet. So our next material, our better option for flashing materials, rather than sort of the composites and those materials, is going to be rigid sheet metal flashing. Copper and stainless steel are examples that are going to be compatible with all air barrier and insulation materials. Of course, they're going to be UV resistant. They're going to last the life of the building. They have, unmatched puncture and tear resistance. The weakness of this category of materials is not compatibility, it's installability. These are prefabricated parts. They're going to be And when you're dealing with anything prefabricated and you bring it to the job site, sometimes the measurement are different on the wall. In the field, something like this is probably going to be addressed with a peel and stick membrane. So we said before that our assembly is only, or our system is only as strong as the weakest material. So in this case, what you've done is you've taken a system with 100-year durability, and if you're lapping it or patching it with a peel and stick, you just reduced it from 100-year durability to 20-year durability, which I've heard described as it's like putting bicycle tires on a Lamborghini. So the joints and laps in these materials are intended to be soldered, and so sealants and adhesives simply don't perform as well. A better option to these is going to be flexible metal tape, which does a good job. These are self-adhesive. So even though we're saying rigid sheet metal here, to be more specific, copper and stainless steel are the materials that you want to use. You want to stay away from galvanized steel and aluminum. They're discouraged because they are subject to some corrosion in fresh water. So the rigid sheet metals, it's expensive. High labor costs, high material costs, tends to be more waste, but it is an excellent system, hard to beat when installed by the correct craftspeople. In a perfect world, we could combine the installability of self-adhere flashing with the compatibility of rigid metal flashing. And so if we do that, and there are some products out there that fall into this category, you come up with a flexible metal flashing. And you can see that stainless steel is highlighted here. There are also some flexible copper fabric flashings as well. In the case of stainless steel, you're talking about something that's going to be 3 times stronger than peel and stick. It's going to have a lifetime durability like sheet metal. As I mentioned, it's also going to be available in copper. So some additional advantages besides those and it being UV resistant is that it's going to have enough stiffness that where you're crossing the cavity space, which we're talking about masonry veneer, so there should always be a cavity space. It has the ability to span that gap without any additional support. It's not going to give you that, what's the word I'm looking for here? It's not going to droop across the space. You don't need an additional material to support it. Because of its flexibility, it also works well for unique flashing situations like some different window shapes. And this is also available with sticky back or self-adhered. And so it can be used without a drip edge also. So when you take a look down in the bottom, the last 4 rows of the chart here are all your stainless materials. And you can see in this case, there are no compatibility issues when it comes to stainless flashing materials and any of the air barrier or insulations. So if we take a look at how it might read in your specification, it might look something like this. So you have the metal flashing, and you can see that the flexible stainless is shown here. And then also an option for a flexible stainless that is self-adhered. And of course, if you wanted to use a flexible, incorporate a flexible copper here, you can do that as well. So, some masons prefer the rigid sheet metal. Obviously, this is an option that the labor and material cost is going to be much lower, but because they like metal, this is something that can be a potential transition for them. If they happen to like the self-adhesive flexible flashings, in this case, they're dealing with a material that is very similar in terms of its installability, but it provides some additional durability. So in either case, whatever material they're used to, this is an option that is a potential easy transition for them. Flashing should always be mechanically fastened. You never want to rely on just the adhesive, even if it is a peel and stick or self-adhesive membrane. I'll just pose it to you this way as a question. What adhesives are you aware of that last as long as you expect your building to? So for that reason, you always want to mechanically fasten your flashing. In the top right there, you can see there are two termination bars. The termination bar is is used to provide that mechanical attachment. You have a flat one, and then you have one here with an angle at the top for a caulking flange. That's recommended. So as we take a look at some other materials, one to consider is cavity drainage material. This is something that can definitely improve the performance of your wall assembly by breaking up your mortar droppings. With these materials, anything that you choose should have the ability to catch mortar at different heights and break it up. So if we take a look at the two materials here, you can see this has a dovetail shape. And so because of that, some of the mortar falls on the higher part, some of the mortar falls on the lower part. That breaks up the mortar and ensures that there's always going to be a path that water can flow unimpeded. In this case, there are some materials that are flat across the top. If they're flat and they don't have some ability to catch mortar at different heights, then it's possible that all that happens is rather than your mortar all being concentrated down at the bottom, it just moves up and you have a mortar dam higher up in the wall. That's something that we want to avoid. In either case, your drainage material should occupy the entire thickness of the clear space. So if you have 2 inches of drainage space between the insulation and the brick, then your drainage material should be 2 inches thick. Otherwise, there is still a potential that it can be clogged with mortar. So if we take a look at our specs, here's the term bar. You can see we've highlighted the sealant flange at the top. And with the drainage material, in this case, dovetail shaped notches is called out. There are others out there besides just a dovetail shape. There are other configurations that can work. So if you find that language from those manufacturers, you can incorporate that into your specification as well. So the next component is insulation. And for insulation, we're going to be moving to Division 7. For the most part, your location in the country is usually what drives the type of material that will work best, but there are some other considerations as well. There are at least 4 characteristics of the insulation that we need to consider. One is the R value, or the thermal resistance. Higher the R value, the higher the resistance. But we typically want to balance that with the thickness. The higher R value we get per inch of thickness, we end up with a thinner wall assembly, which is equivalent to lower material costs, lower labor costs, and better performance overall. We obviously want to consider fire performance. That is a compatibility issue. And so we need to come up with a combination of insulation along with the rest of the components in our wall assembly that's going to provide the fire resistance that we need. So fire performance, a compatibility issue, the thermal performance and thickness, more of an installability issue. And then, of course, in terms of moisture, the insulation has to work in combination with the other components to reduce water intrusion and also handle things like condensation. So that's a compatibility issue there. So if we take a look at some of the continuous insulation requirements by climate zone. So if you happen to be really, really familiar with the code requirements, You know that there is a group R sub with alternate requirements for each of these zones. That's the exception to the rule, so I'm not considering group R here. But I've included both mass wall, which we would use if we had a brick and CMU assembly, as well as a metal frame, which is going to be obviously pretty common for a lot of commercial wall assemblies. So what we're looking at is the continuous insulation requirements for each of these for each climate zone. And you can see it ranges from about R5 for a metal frame wall, because keep in mind, this is an R5 in combination with bad insulation between the studs as well. Mass walls don't have that insulation, or may not have that insulation within the wall itself. It's relying only on continuous. So that's why the requirement is a little bit higher here. So if we take a look, we're ranging between 5 and 7.5 for metal frame walls, and between 5 and 15 for mass walls. Most of our country is a bit more than half is going to be in the first 5 zones. And then we've got a significant portion that's in climate zone 6 and just a little in climate zone 7. So we're going to pay attention mostly to this area, but we'll keep an eye on this as well. All right, so insulation types. First one is extruded polystyrene. Advantages, it's got a good R value per inch. It's also available in 4x8 boards. Disadvantages is this is one of the materials that you're going to have an NFPA 285 approved assembly for. It's one of the most familiar products that's available, and because of its combustibility, it has to be protected at places like window and door heads. So if we compare that, we take a look at R values per inch thickness, we can see that mineral wool is there at about 4.2, extruded polystyrene at about R5, polyiso, cyanurate at about R6 per inch, and then spray foam at about R6.5. And these are probably the 4 most common insulation types that would be used. So the next option is mineral wool. This is a good option for green building projects, for LEED projects. Another advantage that it has is this is non-combustible material. You don't have to have an NFPA 285 approval for this, which I think is one of the primary reasons why people use it, especially considering that it has the lowest R value among the commonly used material, which means you have to use more of it and your walls are going to be thicker as a result. Another downside is that this only comes, I believe, in 16 and 24-inch sheets. So you will have the additional joints there. And it can be difficult to use sometimes with an outboard veneer tie. An outboard tie, as it is attached, can compress the insulation, which may cause some gaps. Polyiso is a material that's another foam insulation. So it does have the same NFPA 285 considerations, but it gives great performance in cavity walls. From an NFPA 285 standpoint, it is a thermoset material, which means that after it hardens, it can't go back to liquid form. So it does provide slightly better NFPA 285 performance or fire performance, slightly better fire resistance. These are either foil or fiberglass based, which may be a positive or a negative depending on where you are in the country and whether you want a vapor barrier as part of your insulation or not. In the case of a foil face, that foil facing may also help from the standpoint of a radiant barrier, which is going to improve your overall thermal performance. These materials can be used, polyiso with the facing, it can be installed and incorporated as part of an air barrier when detailed properly. Disadvantage is that some tests show that the R value diminishes somewhat in lower temperatures. So here's a look again at what this all boils down to, and the thickness of these continuous insulations that's required to reach R10, continuous insulation. So you can see for polyiso, in order to get to R10, you need about 1.5 inches. For XPS, you need about 2 inches. And for mineral wool, you would probably need about 2.5 inches in order to get to R10, which is going to cover you in most of the country. Where I live, in a lot of places, we're talking about metal frame wall, you only need to get to R7.5, which is going to be, 1.5 inches for polyiso or XPS, but you're going to be in the 2-inch range for mineral wool. If you need to go above that, if you're up in this area where you've got to go above 10, then again, the same holds true. You're going to need more mineral wool than those other materials. And then we have spray foam. In the case of spray foam, like rigid metal flashing, when it's done correctly, this may be the best option that's available. However, because you can see it has a high R value of about 6.5, it can also act as an air barrier, which eliminates a step, and it also can seal around ties and other penetrations. Inconsistent thickness, though, is one of the things that can be problematic for both outboard and inboard ties. With an outboard tie, you don't have a flat plane that something with a gasket or a washer head, for example, can actually seal against. If you have an inboard tie, if it's sprayed on too thick, then it may actually cover the part of the backing part of the tie that your embedded part is supposed to connect to. Another thing to consider is that this foam, as it cures, it's an exothermic reaction. It creates a significant amount of heat, and it can actually melt some of the flexible flashing materials. So that's a compatibility issue that you need to be aware of. And another reason why the metals work well. Last component we'll discuss then is the air barriers. Obviously, these have to work in conjunction with the other materials in order to achieve its goal. And the goal of the air barrier is to control unintended movement of air in and out of the wall assembly. So it's similar, you can think of it as a glove for the building. It's trying to reduce airflow, reduce moisture flow, and it also has an impact on the performance of the insulation. So when we look at the way that moisture infiltrates through a building, it happens through diffuse flow that's actually moving through materials. And that's what vapor-resistant materials help to address. And then we have channel flow, and this is where air barriers come into play. And much more moisture comes in through channel flow than it does actually moving through materials. So this is where you've got deficiencies in the buildings. These are the gaps in your assembly, such as around electrical, particularly around penetrations, things like that in your wall. So characteristics of air barriers, they need to be air impermeable. Continuity is key. If it's not continuous, it's not an air barrier, or at least it's not an effective one. It has to be able to resist both positive and negative loads, and it needs to be durable. These are the 4 characteristics of an air barrier per the Air Barrier Association of America. And again, we can also add compatibility here as another characteristic. Flexibility must also be built in because all materials are going to move, and these air barriers are not only going to be on the wall, but they also have to transition to your roof and to your floors as well. So types of air barrier materials. You've got self-adherent membranes, liquid applied membranes, spray foam can be used as an air barrier. Board stock materials. These are sort of the base materials. Things like polyiso, drywall, sheathing. Everything else is sort of an improvement on these. And then you can also see commercial building wraps and factory applied membranes to the sheathing. That would be something like the zip system, for example. So fluid applied and sheet applied materials are both available in permeable, air permeable, in vapor permeable or non-vapor permeable. Most of the time, the safest bet is going to be to go with a permeable material. However, some climates, some applications, and the impermeable will be better. Uh, Typically, the manufacturer of these materials will be able to provide a recommendation. In a lot of cases, they can even run simulations for you to let you know what the best material is going to be and how it's going to perform in your assembly in conjunction with your installation. So one of the advantages of a sheet material is that you're always going to have a uniform thickness and you don't have to worry about cure time. On the other hand, one of the advantages of a fluid applied material is that it's going to be able to seal around your inboard ties. So you can see here that the sheet material is marked as not appropriate for CMU. So if we take a look, we go back to this, we take a look at this CMU wall. We're using an inboard tie in this case. And so you've got all of these little eyes for the pintles that are hanging out of the wall. If you've got a sheet material, then you have to detail to try to make sure that water and air don't get in at each one of those. That would be a nightmare. Right? So here's a summary, quick summary of everything that we've taken a look at today. When it comes to joint reinforcement, less is more. Only use the 3/16" wire when it's necessary, because from an installability standpoint, the 9-gauge is going to work better for you. When it comes to your veneer anchors, always remember to consider the insulation that's being used. Some work better. Inboard ties work better with some insulation types. Outboard ties work better with others. When it comes to flashing, treat it as a system and consider its compatibility with other products. When it comes to insulation, know what your options are. Know your R value per inch. And when it comes to your air and vapor barriers, they have to be continuous and they have to tie into the adjacent building components with proper detail. So that's a quick summary of everything that we've talked about today. And that gets us to the end of our AIA program. Before I answer questions, there is one other thing that I want to share with you. And that is that everything that we talked about today can be summed up. If you go online and you go to rcat.com, I'm going to put Glen-Gery here, and you see a company overview. You'll see all of the nice products that we have available to you. But if you scroll down near the bottom, one of the things that you'll see is there's a masonry accessories section. And that's what we've been talking about today. If you click on technical details, there's a guide specification there that will have all of the stuff that we talked about today and all of our recommendations for these things. So I wanted to point that out to you as a resource. We also have a team that's happy to help you. We have a masonry accessory specialist on our staff, part of our BDM team. So I just wanted to share that with you. With that, that is the end of our program, and I will open it up to any questions that you have. I see that there's three that are already here. I'll answer the first one from Laura. Laura says, which one of the ties work better with the continuous insulation? I think we provided some information that answers that question in part. It does depend on exactly what insulation that you like to use. But, again, with mineral wool and spray foam, your inboard ties, and when it comes to your board materials, your outboard ties for your foam insulation, your board foam insulation, like polyiso and extreme polystyrene. Okay. I see a question from David. Is there a type of joint reinforcement where the wire running parallel to the face of the wall undulates up and down 3/8 inch to define the height of the joint while allowing the mortar to extend the full depth of the joint? I am not aware of a joint reinforcement type like that. So that's the simplest answer I can provide. I don't know what I can add to it other than that, but I am not aware of one. So if there are any other questions, I'll give everyone a chance to type those in. Meanwhile, Brian, is there anything that you'd like to add?
Just a reminder that for those that stay on for the duration of the course, they will be receiving a certificate of completion later this week. There will be a link to today's recording. And also we have another webinar coming up on Wednesday, May 5th at the same time, and it is Inspirational Global Projects with Laura Robertson. So everybody should attend those. And it looks like we don't have any other questions coming in, so I'm going to go ahead and close out today's session.
Thank you, everyone.